Differentiation is a big question, and a lot of people asked about how do I cope with students of varying abilities in my classes. And let's just acknowledge for a second, there's lots of different reasons why there is a range of abilities, okay? Number one, there was one student who, one pre-service teacher who said, I went to this school and in the Extension 2 class, like 20 out of 24 kids were tutored within an inch of their lives. So obviously they know a lot more, well, they've encountered a lot more mathematics than the other students. How do I cope with that? There's also, for example, if you guys are familiar with, like in regional New South Wales, did anyone come from regional New South Wales, by the way? So if you guys have all grown up in metro or even overseas, right, you're probably used to a school where there was a year 7, 8, 9, 10, and there were like multiple year 7 classes, multiple year 8 classes. But as you head out into, say, regional New South Wales, right, what you'll find is there are these things called small schools and central schools. And what that means is, instead of being, say, primary and secondary, a central school is kindergarten all the way up through to year 12. It's smaller, it might be 250 kids all the way from kindergarten to year 12. And so as a consequence, you don't have enough. Like, think about that, 250 kids across 13 grades. So you've got something like, you know, not even 20 students per grade. So you might have stage classes. So there's just a stage 4. There's not a year 7 and a year 8. So as you can imagine, there's a very broad range of academic ability in there. And then there was this really interesting piece of research. If you guys haven't heard of it before, you should absolutely go Google this, right? Scaffolding numeracy in the middle years. This is a research project that, like, when you guys hear the phrase middle years, what does that mean to you? Have you heard that phrase before?
Maybe 7 to 9.
Yeah, that's pretty close. 5 to 8 is generally, which is pretty much in that overlapping ballpark. I mean, it's what it sounds like, right? Middle years, okay?
What's like in America?
Yeah, in fact, yeah, in the US, they literally have these things called middle schools, right? That you'll find in a few spots, particularly in non-government schools, even here in Australia, there will be such a thing as the middle school. Anyway, scaffolding numeracy in the middle years, Victorian research project, and it was trying to understand, you know, there's this well-known struggle that students make from primary into secondary, you know. They'll have a big change in their attitude towards maths or in their attitude and sort of achievement in maths. Here's a question I'm going to pose to all of you that came out of this research project, and I'll be interested to see if anyone gets this answer right, because I got it completely wrong. So, which gives you a bit of a clue. One of the things they did was they got an average year 7 class, right? Actually, they got many year 7 classes. And then what they did was they said, let's try and rank these students according to their mathematical ability, right? And then what they did was across an average, say, class of 30 students, they would then say, okay, what kind of, from the, you know, the most struggling student to the most academically advanced student, what's the actual academic range, right? Now, obviously, you'll find some really extreme examples, and then you'll have some classes that are quite homogenous, and then they tried to average that all out. I want you guys to make a guess. Make a guess, what did you think they found after doing work with and assessing thousands of year 7 students, and then say, okay, let's just take a stratified sample, average class of 30, what's the range that you might find in a class where what they've done is they've tried to stream it, right? Like, so they've ranked the classes and so on. Look at each stream class. What's the difference between the top kid and the most struggling kid? Anyone want to have a guess?
10%.
10% difference? Yeah? Okay, like when we have a look at, because we have streamed these, right? We've ranked them intentionally. Does anyone want to give an advance on 10% different?
That sounds about right.
Sounds about right. 30% is a lot more than 10%, right? Like, that is what you're suggesting is, you know, you've got, if we do the test, let's give them all the year 7 maths tests, right? And on average, within this class, you'll have, say, students who hit 50% and students who hit 80. That's a 30% gap, right? Over many assessments. Anyone want to advance on that? 10%, 30%?
I would say 20%.
20%? Just because, yeah, safe option. Well done, Ewan. That's fantastic. All right, it's like that way, no matter who's right, I'll be some, you know, hedge your bets. I was just like you, completely shocked by the answer. The answer wasn't in terms of percentages, because percentages would be saying, yep, you've done the same test, right? Say on year 7 maths, right? And we found you vary or you deviate in this way, right? What they found was, doing the same test, the variance was way too high. It was actually over 100%, right? So what they had to do was they had to say, let's actually look at we can't just assess you on year 7 content. We're going to have to look at, like, there's some really bright students in there. They're not just getting 100% on a year 7 test, they'll get a really high mark on a year 8 test or even a year 9 test, right? And so then they said, okay, well, there's also not just really gifted students, there's also students who are struggling along. They're getting 0% on a year 7 test. They're below, so it's like we've got to find some lower test to be able to get them, right? So in fact, the average discrepancy was not in percentage points across 1 year. The average discrepancy was in years. Get this, not 1 year of academic difference, not 2 years of academic difference. Like, think about what that would mean, by the way, right? What that would mean is, in your year 7 class, you've got someone operating at a year 6 level and someone also operating at a year 8 level in the same class, right? It wasn't 1 year, it wasn't 2, it wasn't 3. Are you ready? Average year 7 class, where they try to rank them. 8 years. 8 years. So there's someone in that class, in that year 7 class, and they're operating at a year 3 level, right? And there's also someone who's ready to meet differential calculus in year 11, right? That's the range you're finding in a streamed year 7 class. So this question, like, and I think it's fantastic. Why? By the way, if you haven't looked at that, just sort of pass it around. You'll see the questions that have been asked. This is why differentiation is such a big deal, right? Now, you might think this is a long answer to give, being that I haven't even started answering your question yet, which is like, how do I do it, right? The reason why I'm spending so long talking about this is because there's schools of thought that say it's impossible to differentiate. Like, you can't do it. Don't even bother trying. Right? Now, I've just given you this very long prologue to try and justify the fact that I think that standpoint is extreme and probably mistaken. You are going to have, this is just the reality in your classes. You're going to walk in, huge academic range, okay? So what do? I'll give you a few suggestions. Number 1, you guys have heard the phrase low floor, high ceiling? Right? So we want to choose tasks and activities where that student who really is only operating at a year 3 level, they can actually get on board. They can actually do something. They're not going to do it to the same level of sophistication or depth as the other students, but at least they can participate, right? And then we want tasks that actually expand with the intellect of the student who's trying it, right? So, for example, I think I might have to some of you a few weeks back, I might have given you this task where I said, imagine taking the digits 1 to 9, and then arranging them into a sort of vertical sum where you're adding 0 point and then you've got 3 decimal places, and 0 point, 3 decimal places, and you're adding up, and I want you to get as close as possible to 1. Okay, so for example, you might choose 0.123 plus 0.456 plus 0.789. Add them up, what do you get, right? Now, spoilers, if you chose those exact 3 numbers, you wouldn't get anywhere close to 1. So you'd start rearranging digits to try and get closer and closer. Now, as you do this, what you're going to discover is, this is a very cool activity in some ways because you can't do it. You can't add up to 1. And so then some students will start to realize, okay, I can get close. How close can I get? Like, how close is actually possible? If I can't get 1, what is the minimum distance, as it were, right? Turns out the minimum distance is 0.001, because you can get 0.999. That's the closest you can get. How do I know that though? How can I prove that? How can I actually construct, say for example, an algebraic proof, which is actually not that difficult, to show that that's true? Hi, come on in. Now, can you see that's a task which has a very low floor? Like, you can just start adding numbers, right? You could even give students a calculator and not worry about their ability to do the arithmetic operations, right? And then it goes all the way up to, you could give this to an extension 2 student and say, prove it to me. Like, in nature of proof, give me a deductive proof that shows me why it's impossible to get 1, and the closest you can get is 0.999. By the way, you can't get within 0.001 on the other side. You can't get 1.001, but how did I know that? Answer, I know the proof underneath it. So you see, that's a task which sort of differentiates itself. It provides students an access point depending on what level they can engage with the task. So that's my first thing, right? Task selection is probably the biggest practical question that you as early career maths teachers, when you get into the classroom, you have to pose this question to yourself. What examples am I going to give? What questions are my students going to attack so that they can develop understanding? It's a big question, right? That's my first suggestion. The second suggestion is you need to spend some time getting to know your students really well. Have you guys encountered the Australian Professional Standards for Teachers yet? Have you seen those? Yep. So there's 7 standards. Do you know what the first 2 are? Because most people don't remember what 4, 5, 6, 7. It's like, oh, what are they? They're somewhere in there. The first 2, you've got to know them, non-negotiable. Does anyone know them yet?
Students and create a safe and supportive environment.
Very close, well done. So number 1 is know your students and how they learn. Number 2 is know the content and how to teach it, right? The safe learning environment, I think it's number 5 if I'm not mistaken. But anyway, the order is not so important down the line, but 1 and 2, they're there for a reason. Does it make sense to you that you cannot give students something appropriate to them if you don't know anything about them? Does that make sense? So you will very quickly learn 20% of your class. 20% of your class will be composed of the 10% of kids who are super bright, they have an answer for everything. It's like, Nicholas, put your hand down. I know you know, we've already established this, right? I don't need you to tell the class, to demonstrate to them your knowledge. I actually need them to all understand, right? That 10% you'll learn right away because they'll be up the front of the classroom anyway and they'll have their hand up all the time. You'll also learn the opposite 10% of the class who are causing you trouble constantly. Michael, sit down. Michael, on task. Come on, Michael. Have I taught you anything, right? Michael, I need to speak to you outside. Those students you'll get to know also pretty quickly because for obvious reasons. In the middle there though, right? You've got to be quite thoughtful and strategic about what do you do to help yourself know them, okay? I'll give you a really practical trick that I learned in my 3rd or 4th year teaching. You've got your roll of 30, and what I did was I broke it into 10 chunks. 3 students, right? 3 students, 3 students, 3 students. I just did it alphabetically. You can do it in any order you like, right? And I made sure that every time I saw that class, for me, 8 or 9 times a fortnight, right? 8 or 9 times a cycle. Those 3 people at the top of the list, I would talk to them. I'd have an actual conversation with them. I'd look closely at their work, and I would make sure in that lesson, somewhere within the 50 minutes, I would get to those 3 students. Maybe I'd get to others as well, but those 3, non-negotiable. And then the next lesson, I'd look at students 4, 5, and 6 on the list. Now, why do you think, audience participation, why do you think I did that? Why do you think I had to break it up in that way? Think about how this relates to the 20% that I said you'll learn really fast.
So you have enough time to actually get to know those students rather than just a quick let me have a look at your work, hi.
If you want to try and have an interaction with all 30 of your students in the course of 50 minutes, how much of an interaction are you actually going to have? Not very much of one. You'll not get to know them in much depth, right? If you just say, I'm going to get to know them in depth and have proper conversations, you will only have them automatically with that smaller subsection of the class that gets your attention for one reason or another. And there's this big other section of the class, 80% of the students, who you need to go out of your way to look at their work closely when you're marking books. Collect their books, right? But look at these ones and pay more attention to them, right? If you don't have a systematic way of doing that, you will get all the way through first term and you'll still not know who some of those students are because they haven't gone out of their way to get your attention. They're quite happy with no attention, actually. So these kinds of things are mechanisms you can use to help you know the students better, and that enables you to suit their needs better. Does that make sense? One final suggestion for you, because I want to make it very practical, right? Typical lesson, I am 99% certain you've all done this because you've been on at least maybe 1, maybe 2 pracs, that kind of thing, right? What do? You go up the front of the classroom, you start explaining something, right? And then you pose a question to the class after you've explained it and said, do you understand? And there will be some nods. And then you say, I'm not sure about that. I want to ask a question to see if they really get it, right? So you pose them a question based on what you've just explained. A few hands go up. Someone, you select a student, they give you the right answer. How does that feel when they give you the right answer to a question? That's good. It's yes, success. Okay, I can move forward now. I can progress with my lesson plan. That's good. I only allotted 8 minutes to this part. Thank goodness I can move forward, right? Except you can already tell by the way that I've couched the situation, there's a big problem with that mechanism for formative assessment, right? Whose understanding have you checked? 1 student's, right? Maybe 2 or 3 if you saw a few hands up and you're at least a few people know the answer, right? It's probably going to be the same students putting their hands up over and over again, and you don't know actually if it's them understanding because you taught them or them understanding because actually they've encountered this before, maybe they had a tutor, or them being able to produce the right answer when they raise their hand without understanding why it's the right answer. Like, those are two different things, right? So therefore, like, how do you get around that, okay? Because you don't have time to say, okay, I've asked one student, thank you, next, and like, you don't have time for that, right? Have you used mini whiteboards in your classes before? You ever done this? So if you have, fantastic. Mini whiteboard is just like A4 sized, right? And you can write on it. Importantly, you can write with a whiteboard marker and you can write large. And what I'll do is I'll pose the same question, right? And I'll say, okay, class, like, put something down on your mini whiteboard. I'll give you 45 seconds. Do that. Do it in silence. Okay, everyone, hold up your mini whiteboards. Let me see, right? Now, do you see how different that is to someone raise your hand and tell me, right? Because immediately it makes student thinking visible. And it tells me right away, I'm like, oh, half of them have it right, and half of them have no clue. I wouldn't have known about that half if I just relied on them raising their hands. Does that make sense? I've got to go back and explain this better or differently. So these kinds of things ensure that when you're differentiating, you actually understand what students understand and what they don't. And that's really critical. Okay, so I guess what I'm trying to say is differentiation, 50% of it is actually assessment, and not like summative assessment, the stuff at the end. It's the formative assessment you're doing every single second of the class. I've been assessing them before I ask the question. I'm actually looking at their body language, I'm watching what they're writing or not writing, and I'm using that kind of mechanism for engagement.